Hi, so I have this problem on the board. I have a quadratic 25x squared minus 40x minus 9. And what I wanted to go over was factoring this using Vieta's formula. And so what I've done, I have on the right side of the board, I have a generic quadratic ax squared plus bx plus c. And then all Vieta's formula tells us is a way to find not the root, each root, but we can find the sum of the roots and we can find the product of the roots. And this actually works for any size polynomial, but particularly on this video, I'm going over it for a quadratic. And for a quadratic, the formula is just this. The sum of the roots is going to be minus the second term, b, minus b over a. And the product of the roots, alpha times beta, is going to be c over a, c divided a. There's a similar formula for larger quadratics. I have a video that I did a couple months back, and it was on using Vietas on a cubic. So I'll give a link to that, and you can check that out. But so first for this quadratic, 25x squared minus 40x minus 9, first we want to find the sum of the roots. So the sum of the roots, we're calling our two roots alpha and beta. So the sum of these is just going to be minus b over a. So minus b is going to be 40 over a is 25. And I'm just going to reduce that to 8/5. So that if we add the two roots together, we should get 8/5. Then the product of the roots, alpha times beta, is going to be c over a. C is minus 9, and a is 25. Now what I usually do here, just because I don't like working with the fractions, I think most people don't really like working with fractions as much. So what we can do is we can multiply through, like in this, what we can do, look at this and we can multiply through by 5. And so let me come down here. So if we multiply both sides by 5, we're going to have 5 alpha plus 5 beta. It's just going to equal 8, right? Because the 5s are going to cancel here. Okay, so we have a new equation here that has the fraction removed. And then similarly, we'll do this for the second equation, but instead of multiplying, we want to end up with 5 alpha and 5 beta. Let me show you why. So to have 5 alpha times 5 beta, we're going to multiply through by 25, just 5 squared. So that's going to cancel the denominator, and again, we'll have an integer. So we have 5 alpha times 5 beta equals minus 9. Okay, good. Now, so what we've done is we've gotten this just to be a little bit easier to deal with. What I can, even to make it a little clearer, what we can do is we can call 5 alpha A, and we'll call, I don't really want to call it B because it's too similar. Let's call it C. So we'll call 5B equal to C. We'll rewrite this in terms of A and C. So we're going to have A plus C equals 8. A times C equals negative 9. Now at this point, I'm usually going to basically guess and check. But if we're working with integers, it's usually not too hard. So what we want to do is we want to look at the different factors of minus 9. This usually, I mean, in this case, it kind of jumps out to you, but I just want to show you the different ways we can multiply this. So it could be 3 times negative 3. It could be 9 times negative 1, or it could be minus 9 times 1. That looks like that's all the possibilities. There's only 3 different possibilities. And what we want is we want to look at these and we want to look at which of these is going to sum to 8. And the answer is going to be this one. We add 9 and negative 1, that's going to be 8. So we want this set of factors right here. Everything else won't work. So then, now we don't care which one's A and which one's C, but we now have our value. We know that we can say that what doesn't matter. So we'll call A equal to 9 and C equal to negative 1. And then we just need to go back and remember that we made a substitution. We said we said A is 5 alpha, and we said C is 5 beta. And these are the, remember, these are the original roots that we want to find. Those are our two roots of our polynomial. So then all we need to do is divide out our 5. We multiplied by 5 earlier. Now we're going to divide by 5. So we'll divide each of these by 5. All right, that's kind of messy. Divide by 5, divide by 5. And we end up with alpha equals 9/5 and beta equals minus 1/5. So those are our two roots. And sometimes they might just be asking for the root. So if they asked for the two roots of that polynomial, like if they set it equal to 0, that would be your answer. But if a problem is phrased as factor this polynomial, we just have another step to do. So let me show that. Okay, so now that we have our two roots, we can write those in a different way. We can write this as x minus 9/5 times x plus 1/5. And why did I do that? Because the reason I did that is just because you can see that if you were to plug in alpha here, you get 0. And if you plugged in -1 here, you get 0. So the roots are the zeros of the quadratic. And so we can actually write this in this form to show that we have here's our two roots, our two zeros of the quadratic. Now, the only thing that might look a little strange to you is, we have this quadratic this way, and we ended up with fractions. And what we did is, yes, these are the roots of this quadratic, and this all makes sense, but when you have a leading coefficient, you need to include that when you're factoring. So all you need to do is go back to the original problem and take that and bring it right over here. And then you can distribute that in here to make it a little cleaner. Anyway, we'll distribute that, and what we can do is we can call it 25 is the same as 5 times 5. So we can distribute a 5 here, a 5 here. And when we multiply that through, we're going to get 5x minus 9 times 5x plus 1. And then that would be your fully factored, that would be like your factored solution. We have our roots. You can see if you plug these roots in here, you're still going to get 0. And then here we have all integer coefficients. And so that's just the factorization of this quadratic. So you may notice that this actually took a while, and you may say that you could just factor this by hand faster by just like looking at it and saying, oh, we got probably a 5 here and a 5 here, and then looking, and trying different things and seeing what works. And that doesn't work, but maybe your methods of guess and check are faster, and that might be. So Vietas is not always the best way. It's not always the fastest way. It's just another option, another way to look at it, and it can be pretty useful in some situations. And then also for just finding the roots, we use Vietas to find the roots, but you may want to use the quadratic formula, or you may want to use another method to find the roots. Or I suppose, I mean, if you could factor it fast, then you can. If you could factor it to this, not this is wrong, but if you factor it, then you basically have the roots. You can just divide out the leading coefficient, and you could get the roots from here and go from here to here. So just want to let you know that's not always, this is probably not the fastest way, but in some situations it's a pretty good way to solve it. I have a quiz on quadratic factoring. I have the video on using Vietas for solving a cubic, and I'll provide a link to those in the description. Thanks. Have a good day.